Hello everyone, this presentation is on hardware Trojan detection, and so these are the contents of my presentation. First we will discuss the Trojan and its impacts. Then we will see the life cycle of an integrated circuit. We will see the different types of Trojans, the Trojan taxonomy, and then the components needed by a hardware Trojan. Then we will see the various Trojan detection methods. The Trojan detection method that I have used in my project is power side channel analysis, and later on we will see the video demonstration of how I used a logic analyzer to prove that there is a Trojan existing in the circuit. So what is a Trojan? A Trojan is a malicious circuit alteration. It's just an extra circuit added in our design that may have unfavorable impacts on the system. It is a great emerging threat for the integrated circuits and their applications. What are the impacts that hardware Trojan can have? One of the biggest impacts is the confidential information. There can be a leakage of confidential information, and if this confidential information is in important places such as the military or the US Air Force, then this can have really bad effects for the security. And the some of the other impacts it can have is like a device or the system can be disabled, or it can turn off a missile in case of a war, or it can break down as well. Well, where is the Trojan implanted? Like what are the untrustworthy levels where a Trojan can be implanted in the design? Well, this is the life cycle of an integrated circuit. There is a design phase, fabrication phase, testing, and application. The most untrustworthy level will be the fabrication because it is overseas. Most of the integrated circuits that are used are fabricated in Taiwan semiconductor companies and many other semiconductor companies which are overseas due to the cost. Uh, most of the uh, most of the uh, users of IC try to buy the chip from overseas. This is the Trojan taxonomy. Like there are major three differences, or it can be a combination of these three characteristics: physical characteristics, activation characteristics, and action characteristics. In physical, if we can talk about the placement or the structure and the size and type of the Trojan. Activation characteristics, it can be activated externally, that like a remotely or internally. And then action characteristics, it can transmit information, or it can add modification, or it can be a functional addition to the design. Trojan may have only one of the characteristics, or it may possess multiple activation characteristics, and it can be modification, addition, or it can be transmission of info. So these are the components needed for a hardware Trojan. One of them is hardware driver, then a trigger, and a storage. So trigger incites the planned hardware Trojan horse. After a trigger occurs, the action can be stored in a memory or sequential circuit. Driver implements the action prompted by the trigger. So this is until now what we have spoken about what is a hardware Trojan and how it can impact our system, or how it can affect everything. Now we'll discuss about hardware Trojan detection. How are we going to detect these things? Like there are majorly two different ways of doing this. One is a destructive approach where the functionality of the integrated circuit after we apply the detection methods may change, and the other one is the non-destructive, and the one we are going to focus on is the side channel analysis. So destructive techniques were some of the examples: reverse engineering, long-term transistor aging, and as I said, this may destroy the functionality of the IC. The non-destructive techniques is logical testing, side channel and conductive behaviors. And in side channel analysis, we will be using the ring oscillator puff and checking the current consumption by it when the Trojan is in the circuit and when there is no Trojan in the circuit. Implementation of our row puff. There are total 512 oscillators used in design, and then each arrow is manually mapped using the FPG editor tool. Power side channel analysis. This is where we are trying to see the consumption of our design, the ring oscillator puff, and when there is a Trojan in the design, we see that there are fluctuations. That means the design is consuming more current when there is a no Trojan in the design. This is the ring oscillator design. We have used 3 NOT gates and an AND gate. This is the Trojan design used. We used 3 XOR gates and 2 NOT gates. And this is the power analysis of uh, uh, voltage variation, where we see that uh, the current and the voltage is high when there is Trojan in the circuit, and it's low when there is no Trojan in the circuit. Thank you, and we will be seeing the video demonstration of logic analyzer and the power analyzer.